Okay. Good morning, everyone, and welcome to our session at the Prompt Engineering Conference. Today, we are excited to share how we built an AI-powered tutor using a hybrid RAG system.
This project shows how large language models paired with retrieval systems solve challenges in education. We'll walk you through the architecture, key principles, and the outcomes we have achieved.
We'll also highlight how prompt engineering enhances the tutor, adapting to the student needs, retrieving real-time content, and improving through feedback.
By the end, you will see how RAG-based frameworks work beyond education to deliver reliable and scalable solutions.
So let's dive in with an introduction to RAG architecture, the engine that ensures accuracy by merging pre-trained models with real-time data. Now, before we dive into the technical content, let me introduce my co-presenter, Alok Ranjan. Alok is a software engineering manager at Dropbox, where he leads the storage platform team. He holds a master's degree from Carnegie Mellon University and began his career at Cisco, working on network technologies.
Thanks, Saurabh. Over the years, I have had the opportunity to work on impactful projects across VMware, Big Switch Networks, and now at Dropbox. A key area of my focus at Dropbox has been AI adoption, where we leverage advanced tools to enhance operational efficiency.
In addition to his work at Dropbox, Alok is passionate about sharing knowledge and actively mentors engineers at AI startups. His experience in building scalable platforms and implementing AI solutions has had a significant impact across multiple industries.
Thank you, Saurav. I'm excited to be here today to share our learnings and experiences around AI-powered solutions, like the tutor we have developed. Now let me introduce Saurav Suman, my co-presenter. Saurav is an applied AI engineer at Wednesday Solutions, and he has been at the forefront of building scalable AI tools for EdTech.
Thank you, Alok. My focus has been on leveraging AI model to tackle challenges in education and drive innovation in how the learning is delivered. The AI Tutor project is one of the many ways we're exploring the intersection of technology and education.
Saurav's work revolves around creating impactful, tech-driven solutions that transform how education is structured and experienced by students. His expertise has been instrumental in developing the architecture and systems that power our AI tutor.
I believe in using AI not just as a tool, but as an enabler. And I look forward to sharing how we build the system and the impact it has been creating. All right, Alok. Let's discuss the retrieval augmented generation, which is the RAG model that we all know about. The core concept here is combining large language models with external data sources, both structured and unstructured, to overcome the limitation of pre-trained models.
Exactly. Traditional LLMs only rely on their training data, which limits them when it comes to dynamic or domain-specific information. RAG bridges that gap by integrating retrieval mechanism, allowing the model to inject up-to-date and specific data into generation process.
The workflow starts when a user interacts with the system through a generative AI app. This app sends a prompt which triggers the RAG pipeline. The retrieval model, as shown in the diagram, is divided into two parts.
Right. The structured data retriever pulls information from databases and CRMs, systems like Salesforce, SAP, or Snowflake using SQL queries. This ensures that the data is precise and fits well into the query.
On the other hand, unstructured data like PDF or papers is more complex to retrieve. This is where technologies like Elasticsearch and vector databases like Pinecone come in, performing semantic searches to find relevant information.
Once the data is retrieved, it's appended to the user's original prompt, providing additional context. This ensures the LLM generates responses that are not only fluent, but also accurate and relevant to the user's needs.
And this is the real advantage. By enriching the prompt with current data, the LLM avoids hallucinating answers and stay aligned with the domain-specific knowledge.
Yeah. However, managing latency becomes crucial since each query adds overhead. Caching frequently accessed data and using parallel query execution help reduce response time.
Exactly. The architecture can be scaled efficiently with both retriever operating independently. This flexibility ensures that the system performs well under high loads, supporting both SQL-heavy operations and unstructured searches.
And by optimizing the architecture with technologies like Redis and Elasticsearch, along with re-ranking algorithms, we ensure precision without compromising speed.
Definitely. And that's the real strength of REG that makes LLM not just standalone tools, but it deeply integrates as a solution capable of scaling and adapting to diverse enterprise needs. So this slide highlights the core reason why REG is essential. To understand the value it brings, we first need to recognize the limitation of traditional generative models like GPT-based LLMs.
Right. From my experience, these models are great at generating fluent responses, but they can struggle with accuracy, especially when handling specialized or time-sensitive queries.
Exactly. One of the biggest issues that these models are trained are that they train on static data. That means their knowledge becomes outdated over time. For example, a model trained up to 2023 can't provide accurate information on events that are happening or have happened in 2024.
Yes, that's the knowledge cutoff problem. Even though model is great with language, it risks generating outdated or incorrect responses.
Exactly. And there's also a problem of hallucinated responses, content that sounds plausible, but isn't based on any factual source. That's where the RED steps in by integrating retrieval to minimize irrelevant or incorrect outputs.
So the retrieval component ensures the LLM can pull relevant real-time data, right? It's not just relying on its pre-trained knowledge anymore.
Correct. For instance, in a customer support chatbot, REG ensures that system queries the live databases to provide up-to-date product information or policies, preventing outdated or inaccurate responses.
And because it taps into extensive internal or public knowledge bases, the outputs are more informed and contextually accurate.
Right. Exactly. The goal with REG isn't just to generate any response, it is to generate the right response and with the minimum irrelevant content.
And because retrieval adds modularity, the system can easily adapt by integrating new data sources or adapting existing ones to meet evolving business needs.
Yeah. It's like giving LLM continuous access to a dynamic, expanding knowledge base. This makes it invaluable in areas like legal research, fraud detection, where even small inaccuracies can have serious consequences.
And I assume retrieval also ensures consistency, right? If the same query is asked repeatedly, the system pulls from the same sources to maintain a consistent response.
Exactly. By always accessing authoritative resources, the system avoids variability in responses and ensures a consistent user experience.
This really highlights the strength of RAG. It combines the fluency of generative models with the precision of information retrieval systems.
All right. So let's dive into some key challenges that we faced in building effective RAG systems. Starting with the first and most important, data quality. The performance of RAG relies heavily on the quality and the structure of retrieved data. If the data is incomplete or if it is outdated, even the best of LLMs won't generate meaningful responses.
Exactly. Data governance is crucial. Inconsistent data, like old product catalogs or missing fields, can undermine the system. Enterprises need robust processes for data audits, cleaning, and version management to ensure that retriever pulls the right data every single time.
That's right. And the next challenge that we face is latency. Querying external databases introduce delays that can, hurt user experience, especially in chatbots or virtual assistant. Faster response times are essential and every millisecond counts.
And as the data scales, latency becomes harder to manage. Queries involving multiple sources or complex join can slow down responses. Caching and prefetching strategies help mitigate this, but they trade off with data freshness.
Right. And using tools like Elasticsearch or Redis can optimize retrieval speed, but there is always a balance between performance and accuracy. Even with optimization, the system must be carefully architected to maintain smooth interactions.
The third challenge is hallucinations, when the LLM fills in a gap with incorrect information. Even with real-time retrieval, if the retrieved data is ambiguous or incomplete, the LLM might fabricate content.
Right. And hallucinations can be dangerous in the field like finance or healthcare, where misinformation can have severe consequences. So, re-ranking algorithms help by ensuring that only the most relevant data is considered.
Yeah, the key is alignment between the retriever and the LLM. Too much reliance on the LLM increases hallucination risk, while over-dependence on retrieved data might reduce response fluency. Finding the right balance requires continuous tuning.
Exactly. Building effective RAG systems means curating high quality data, optimizing for latency, and fine tuning the interaction between retrieval and generation to minimize hallucinations.
It's challenging, but the benefits, combining the real-time data with generative power makes it well worth the effort.
Right. So now let's move on to a small introduction to prompt engineering. It's the process of designing precise prompts to guide the AI system towards the accurate results that we wanted to give. Think of it as giving AI a clear roadmap so it knows exactly what you're asking and can deliver relevant answers to you.
Exactly. The quality of a prompt can make or break the AI's response. If the prompt is too vague, the AI might generate inaccurate or irrelevant output. But with a well-crafted prompt, the AI produces more focused and useful results.
That's right. A well-designed prompt ensures the model aligns its responses with the user expectations. It is very essential for complex or domain-specific queries. So the clearer the input is, the easier it is for AI to understand the response and respond accurately.
Another benefit is that good prompts reduce hallucinations. The AI's tendency to generate plausible but incorrect information. By refining prompts, we can cut down these off-the-mark responses.
Yes, and from an operational perspective, optimizing prompts saves time and computing power. Even unnecessary response waste resources, whether on cloud infrastructure or local systems. This efficiency become very critical in large-scale applications like customer support chatbots.
That's right. Good prompts also help the AI better understand the user's intent. It's the difference between a vague question like, tell me about finance, and a specific one like, explain how compound interest works. The more targeted the prompt, the better the output.
This is why prompt engineering has become an essential skill. It's not just about using AI, it's just about asking the right questions to get meaningful and relevant answers.
And since models like ChatGPT 4 have inherent limitation, prompt engineering helps us work around those by framing questions correctly and reducing the chances of irrelevant output.
Right. So, in summary, prompt engineering is more than just a necessary technical like importance. It's a way of maximizing the accuracy and efficiency and the relevance of the AI systems. So it makes it really crucial for the chatbots, search engines, and any other AI powered tools. Now that we know the importance of prompt engineering, let's explore three key techniques: dynamic prompts, contextual prompts, and bias mitigation. I'll begin with the dynamic prompts. So dynamic prompts are all about, adaptability. They basically evolve based on the changing input or the user needs. For example, a customer service chatbot. The prompt might adjust based on the user location, interaction history, or the time of the day. This adaptability ensures that the AI provides responses that remain relevant.
Exactly. Dynamic prompts also enable scalability. They allow the system to generate personalized responses on the fly, which makes them crucial for applications like recommendation engines or learning platforms. With static prompts, this level of relevance won't be possible.
Right. Now let's talk about the contextual ones. So contextual prompts are like these are the guides for the retriever and the generator systems towards the specific goal by embedding relevant information into the prompt.
Right. RAG plays a critical role here. For instance, if a user asks, what's the latest policy update? The retrieval model fetches the correct document and the LLM shapes the response accordingly. This reduces vague answers and increases precision.
Exactly. So contextual prompts reduce hallucinations by aligning responses with specific embedded information, which is very essential in high-stakes applications like legal research or medical diagnostics.
Finally, bias mitigation ensures that AI outputs are fair and balanced. Since LLMs can inherit biases from their training data, prompt engineering helps us control these biases by careful phrasing and constraints.
Yes, and it's very easy to trigger these biases. For example, instead of asking who is the best leader in history, which could, trigger a lot of biased response, we can rephrase it as simple as list three influential leaders from different regions. This reduces subjectivity and promotes inclusiveness.
Exactly. This approach is critical in areas like hiring, hiring automation, or financial services, where AI decisions must align with ethical guidelines.
Right. So in summary, dynamic prompts adapt to the changing input. Contextual prompts basically provide relevant context to enhance the precision, and a bias mitigation ensures the output are as objective as possible.
Mastering these techniques unlock the full potential of prompt engineering, ensuring that the AI generates accurate, ethical, and relevant responses, creating a better user experience.
So now let's explore how to design effective prompts for our systems. We'll look at 5 key strategies, and we'll start with the chunk feeding. So chunk feeding involves breaking large pieces of content into smaller and smaller sections, allowing the AI to process them sequentially. This ensures the model doesn't miss critical details and avoid token limitation that could prevent it from retaining very important information.
Exactly. This way, the system avoids being overwhelmed by long inputs and ensures more precise responses. The second strategy is question refinement, where we iteratively improve questions to align them with desired outputs. Instead of asking, "What's the market trend?" you refine it to, "What are the top performing industries in the stock market for Q3 2024?"
Right. The refinement can also happen during interaction, where the system asks follow-up questions to clarify user input, and it mimics how human conversations evolve. So now let's try and discuss contextual prompts.
Contextual prompts embed relevant background information directly into the prompt. For example, a legal AI might include specific case references or clauses, helping the model generate precise responses by reducing its reliance on assumptions.
Exactly. Providing context help guide the AI towards more accurate answers. Now let's talk more about prompt chaining, a technique for managing complex tasks step by step.
In prompt chaining, related prompts are sequenced together. For instance, if you need the AI to gather data, analyze trends, and make recommendations, each step feeds into the next, ensuring the model stays on the track throughout the process.
Right, and this method helps manage complexity and avoids overwhelming the system with a single complicated prompt. The final strategy is handling ambiguity, which addresses vague question to ensure relevant responses.
Right. If a user asks, "How do I improve my business?" the AI could interpret it in many ways: marketing, operation, finance, etc. A better approach would be to rephrase the question or ask clarifying follow ups like, "Are you focused on increasing revenue or improving operational efficiency?" This ensures the AI focuses on what the user really wants.
Right. So all of these strategies, chunk feeding, question refinement, contextual prompt chaining, and handling ambiguity, it all helps optimizing RET systems. Each addresses specific challenges and improves accuracy, efficiency, and finally the relevance of the AI outputs.
And these strategies work best in combination. For example, prompt chaining can pair with chunk feeding to manage complex tasks while maintaining context. Better prompt design leads to a better AI performance, ensuring a smoother user experience.
So finally, we reach the product that we have worked a lot for, and which is the AI tutor. So this application adapts to each student's individual level and pace. This ensures that the learning experience is tailored to their specific needs. This also helps the student progress more effectively, and it reduces a lot of their frustrations.
And the next benefit is curriculum integration. The AI tutor aligns its responses with the specific course material being used. This ensures that the students receive guidance that's relevant to their classes, reinforcing what they have been taught.
Exactly. And now let's talk a bit more about continuous improvement, with every student interaction, the AI tutor collects feedback and uses it to improve. This iterative process ensures the system evolves and becomes smarter over time, delivering more accurate responses.
Finally, there is the added benefit of reduced workload for teaching assistants. The AI tutor handles routine questions like assignment deadlines or basic concepts, allowing TAs to focus on more meaningful tasks such as one-on-one mentoring or helping students with complex challenges.
So now let's quickly see the architecture driving our AI tutor, the hybrid RAD system. So when a student inputs a question like, how do I solve this particular maths problem? It goes through a query processor that uses NLU, natural language understanding, and the query processor interprets what the student is actually trying to ask. It also handles informal phrasing or spelling mistakes.
Once the query is processed, it flows through two paths, one to the retriever and the other to the generator. This is where the real magic happens.
Yeah. The retriever performs a semantic search. It pulls all of the relevant information from the AI tutor knowledge base. For example, if a student asks about how the Newton law works, the retriever finds relevant lecture notes or course content to ground the response. In fact,
Meanwhile, the generator, powered by a large language model, creates a coherent response. If the retrieved information isn't sufficient, the LLM fills in the gaps with its pre-trained knowledge enhanced by the retrieved context.
so the response synthesizer plays a really key role here. It merges the retrieved data with the LLM generated content, ensuring that the final output is both comprehensive and accurate. If the query spans multiple topics like Newton laws and modern physics, the AI tutor combines all of this information seamlessly.
The final output is displayed to the student via the result display, and we close the loop by capturing user feedback. This feedback helps refine our retrieval algorithms, making future responses more relevant. We can also integrate external knowledge sources like public APIs or web resources if students need information not available in their course material. This ensures the AI tutor offers comprehensive learning support, even for advanced topics.
Right. And this hybrid approach reduces the risk of hallucination since retrieved data from trusted sources ground the AI responses. This is particularly valuable in education, where accuracy is like non-negotiable.
The system is modular nature means we can add new data sources or upgrade the LLM as curricula evolve, ensuring the AI tutor stays up to date.
In summary, the hybrid RAG architecture is the engine that powers our AI tutor, delivering relevant, accurate, and context-aware responses. This allows us to offer a personalized learning experience for every student.
And thanks to the real-time feedback loop, the AI tutor continuously learns and evolves, improving to meet students' needs over time.
So now we see the synergy between the hybrid RAG and how prompt engineering they all work together, which forms the backbone of our AI tutor. These two elements work hand in hand to ensure tutor delivers dynamic, relevant, and efficient responses. So now let's take a look at the hybrid RAG part of it. The hybrid RAG combines pre-trained model with real-time retrieval, giving the tutor access to both historical knowledge and updated content. This means the AI tutor isn't restricted to static information, and it can pull in fresh data from internal sources like course modules, updated assignments.
That's essential because education is constantly evolving. If there is a curriculum change or new material added, hybrid RAG ensures the AI tutor retrieves the latest content on demand, so students always receive the most up-to-date information.
Exactly. And this also allows for dynamic responses by blending the LLM's knowledge with real-time retrieval. Even for a multi-layered question, the system synthesizes information from both pre-trained data and retrieved sources. So it ensures the response is comprehensive as well as relevant.
Now let's look at the prompt engineering. It ensures the AI makes the best use of the retrieved data. A well-crafted prompt aligns the retrieved information with the student's needs, guiding the system to process the input effectively.
Right. And for example, if a student asks, explain the Pythagorean theorem with example, the prompt ensures the AI not only retrieves the theorem, but also generates a relevant example and provides a complete response.
And it helps reduce irrelevant outputs. Without a clear prompt, the AI might give generic or off-target responses, which is problematic in education, where precision and clarity are key.
Right. So in summary, hybrid RAG ensures that AI tutor is always pulling in accurate and timely information, while prompt engineering ensures the response aligns perfectly with the student's intent, and together they deliver reliable and context-aware guidance.
This synergy makes our AI tutor stand out. Hybrid RAG ensures content relevance, and prompt engineering aligns responses with what the students are looking for, whether it is a concept review, doubt clarification, or solving complex problems.
Now, all of us have, like, in some time, have always faced hallucinations, which is a very common issue in generative AI, when the system gives responses that sounds right but are actually incorrect. For our AI tutor, the factual accuracy is essential, and we address hallucination through prompt engineering And within this prompt engineering, we'll first try to explore grounding prompts. So grounding prompts ensure the AI responses are actually based on factual data. For example, if a student asks, "What are the phases of mitosis?" The prompt includes a summary from the course material. This ensures that the AI generated answers always align with the trusted information.
Exactly. By embedding context-rich prompts, the AI can pull from reliable sources like textbooks or lecture notes, reducing the risk of hallucinated responses. It also ensures that the terminology matches what's taught in the course.
So grounding prompts also allow the tutor to tailor the responses to specific course content. So if different classes uses different terms for the same concept, the AI adjusts its answers and responds accordingly.
Now, the second technique we use is iterative refinement. This involves analyzing incorrect outputs and refining the prompts to improve future responses.
Right. For example, if the AI gives a partially correct answer to a maths problem, we refine the prompt to guide it towards a complete explanation next time. This ensures continuous improvement.
We also apply iterative refinement by breaking down complex queries. If a student asks, how does photosynthesis work and how is it different from cellular respiration? The AI splits it into two focused prompts. This ensures it delivers clear, accurate responses for each part.
So together, grounding prompts and iterative refinement help maintain the quality of responses, ensuring the AI tutor is both accurate and adaptive.
And building this trust is key. Students need to know that the AI tutor provides reliable guidance, helping them learn with confidence.
So now, in this slide, we'll share some of the key strategies that we have implemented to reduce hallucinations and what has worked for us in enhancing the reliability for our AI tutor responses. So the first, I would begin with adding constraint or limits. So what exactly does it entail? Adding constraints involves setting boundaries for responses. For example, instructing the tutor to answer in one sentence or providing a three-step solution. This keeps the responses concise and avoid unnecessary detail, ensuring the students get exactly what they need.
Right. This is really effective for straightforward questions. If a student asks, what's the capital of France? The AI just says Paris. No need for extra information. Constraints help the AI stay focused and efficient.
Right. The second strategy that we tried out is encouraging citations or evidence-based answers. For complex topics, especially in science or history, the tutor refers to specific sources like lecture notes, textbooks, so the student trusts its answers.
Exactly. It also makes the process more transparent. If a student asks about Newton's second law, the tutor can cite the textbook, saying, according to your textbook, Newton's second law states. This builds trust and eliminates fabricated responses.
Right. So the third practice that we tried is the contextual grounding, which ensured that the AI is always using relevant course material or assignment to shape its answer. If the query relates to a recent project, the AI will use that context to generate a targeted response.
It also ensures consistent answers. When students revisit the same topic, the tutor pulls from the same sources every time, ensuring continuity in their learning experience.
Yeah. And finally, we use query breakdown for multi-step questions. Instead of answering everything all at once, we designed the tutor to split the complex queries into a much smaller prompts. For instance, if the question is how does gravity work, how does it differ on the moon, the tutor handles each part separately and provides accurate answers.
This strategy improves clarity and accuracy, reducing the risk of partial or confusing responses. It allows the AI to focus on one part at a time, making sure the student gets the right information.
So, by combining all of these strategies, adding constraint, encouraging citations, grounding prompts, we have significantly improved the quality and reliability of the AI tutor's responses.
Ultimately, these techniques ensure that every interaction is meaningful and productive, providing students with clear, accurate, and well supported answers that enhance their learning and confidence in the system.
So now we see how we actually evaluate the performance of our AI tutor. So continuous evaluation is very essential for us and even for the AI tutor to stay accurate, relevant, and engaging for students. So now let's start with how we measure relevance. Relevance is actually measured by how closely the tutor responses and aligns with the student queries and scores content. So to find and measure this out, we use semantic similarity and precision recall to assess whether AI captures the intent behind the questions and whether it is delivering useful answers or not.
And alongside relevance, engagement is equally important. We track engagement with metrics like conversation length, response rates, click-through rates, and time on task. These insights tell us if students are actively interacting with the AI and whether it's helping them stay focused.
Exactly. Engagement indicates that the tutor is providing not just accurate answers, but also meaningful interactions. Now, let's look at a process for continuous improvement.
The process starts with feedback collection from both students and instructors. Every interaction generates insights that help us fine-tune our prompts and retrieval model, ensuring the tutor becomes more precise and adaptive.
So, this feedback loop ensures that the tutor evolves in real time, keeping up with the pace with both curriculum and the student needs. And finally, let's talk about accuracy, which is the most critical part of the evaluation.
We measure accuracy with NLP metrics like BLUE and ROGUE, comparing the AI's response to ground truth answers. For more nuanced topics, we also rely on subject matter experts to conduct manual reviews, ensuring both quantitative and qualitative assessments.
Right. And this combination of Blue and Root scores and SME reviews, it will give us a well-rounded view of the system accuracies. It ensures that the AI delivers expert-level responses even for a very complex query.
This continuous evaluation ensures that the AI tutor is more than just a tool. It becomes an integral part of the learning journey, adapting seamlessly to students and the curriculum.
All right. So let's talk about what was the real world impact of creating something like a AI tutor. So we successfully integrated this into several educational institutions, which offered them meaningful support to both students and instructors. And we have been really happy with the responses that we got. So we saw 30% more student interaction, showing increase in engagement. Students were no longer, shying away from asking questions, and there was a 40% reduction in the routine administrative tasks. So, such as answering repetitive questions. So, this allowed educators to focus more on personalized mentoring instead of handling mundane queries.
I face similar challenges in my organization, where redundant queries across multiple Slack channels and support systems were overwhelming. People kept asking the same things. What's the status of Project X? Or where is this API documentation? And it was eating into our productivity. We tackled it using principles similar to the AI tutor. I built a fact-driven AI bot to handle these repetitive queries. The bot retrieves answers from a centralized knowledge base, just like the AI tutor pulls from the academic resources. We had scattered information across Confluence, Google Docs, and internal documentations. Consolidating everything into a unified source of truth ensured consistent responses, regardless of where the queries originated. The real breakthrough came when the bot started to self-learn. As it gathered insights from conversations, it refined its responses, much like how the AI tutor improves through feedback loops. Over time, it adapted to new processes and provided accurate answers without requiring manual updates.
Right. And this highlights how the core principle of AI tutor, retrieval, feedback loops, knowledge centralization can be applied across industries. Whether in education or in enterprise support, the goal always remains the same, which is reduce redundant tasks and deliver context-aware responses efficiently.
Exactly. The beauty of these systems is that they evolve with users, become faster and more accurate over time. Both the AI tutor and enterprise bots like mine grow with their environment, continuously improving their performance.
All right, so let's finally wrap up with the key takeaways from today's presentation. The first and foremost is scalable solutions. The combination of prompt engineering and RAG ensures that our AI tutor scale perfectly, handling all of the complex and frequent queries in a very efficient manner while maintaining the high quality responses for every single learner.
Exactly. Scalability isn't just about handling volume, it's about maintaining accuracy and relevance at scale. That brings us to second takeaway, better results. With customized, context-specific prompts, we ensure students receive precise and meaningful answers. This approach builds trust, enhances engagement, and creates a better learning experience.
Right. And now the final takeaway. the continuous improvement part. Our AI tutor evolved with every single interaction that it did, and that's because we collected feedback, we refined prompts, and we improved it over time. This ensured that it stayed aligned with the curriculum and adapted to the new topics and always the changing needs. And this finally brings us to the end of our presentation. Thank you so much for your time and attention today. It has been great walking you through the AI tutor and how it leverages to the cutting edge technology like RAG and prompt, which is making education much more accessible and effective for everyone.
Yes, thank you. We hope the insights we have shared today gives you a clear idea of how the AI tutor can revolutionize learning environments and how similar principles can be applied across industries to solve real-world problems.
Yes, and if you'd like to connect with me or discuss any ideas further, you can scan the QR code on the left to reach out, and I would love to connect and explore how we can collaborate on any other projects similar to this one.
And if anyone is interested in exploring more about the work I'm doing at Dropbox or has any questions about implementing similar solutions, feel free to scan the QR code on the right. I'm always open to networking and sharing knowledge.
Once again, thank you all for your time, and we look forward to your questions, feedbacks, or any other discussion that you would like to have. And we really hope this session has been as exciting and informative to you as it has been for us.
We're both here for any follow-up questions or ideas you would like to explore. Don't hesitate to reach out. And thank you again.
Thank you.